Good morning to all. Myself Dr. K. Manoharan, Associate Professor, Department of Biomedical Engineering. So today class we are going to discuss about Introduction to 8085 Microprocessor. So 8085 is an 8-bit microprocessor. This is the first introduced microprocessor in commercial. So the 8085 microprocessor, it was developed by Intel in 1976. It is an 8-bit microprocessor. It will be widely used in embedded systems and educational applications. So this is based on von Neumann architecture. So where the program and data share the same memory spaces. So we have two types of architecture. One will be von Neumann architecture and another will be hardware architecture. So in hardware architecture, we use separate program memory and separate data memories. So here this 8085, it supports the von Neumann architecture. The same memory will be shared for both program and data. So this is an 8-bit processor. So the ALU can process the 8-bit at a time. So the features of 8085 microprocessor. So first one will be, it is an 8-bit processor. It can process 8-bit at a time. Even we can do the 16-bit operation, but at a time it can process the 8-bit only. So lower 8-bit can be performed. After that completion, higher 8-bit can be also performed. But at a time it can perform the operation of 8-bit. Second, the number of address lines. So it have an 16 address lines. So this it allows this address up to 2 power 16. So 2 power 16 is a 65536, or we can say it is a 64 kilobyte. So by using this 8085 microprocessor, up to 64 kilobyte memory can be accessed. This memory can be shared between the program and data. So it consists of 16 address lines. So these address lines will be unidirectionals. And it consists of 8-bit data bus. So only we have an 8-bit data bus. So because its ALU is 8-bit, so at a time we process 8-bit only. So that's why we use only a 8-bit data bus. So here we have an bidirectional data bus. Why the reason is, address bus, always address will be generated by the microprocessor, and then generated address will be sent to the memories or devices. But data is not like that. Sometimes we read the data from a memory. So there we need to transfer the data from memory to microprocessor. After completion, we store the data. There the data should be stored, moved from a processor to memories. So we need to transfer the data from both directions. That is memory to processor, also processor to memory. So the clock speed, it operates on at the 3 megahertz. It's making it suitable for a moderate speed application. So 3 megahertz speed it will be supports. So 1 by 3, so around 0.33 in terms of, we can say it's a milliseconds. So normally instruction to execute will be 0.33 in terms of not milliseconds, it is a microseconds. So because it's a 1 by 3 into 10 power 6. So this will be a 10 power 6. If you go bring it to numerator, it's a 10 power minus 6. It becomes microsecond. So 1 by 3 is a 0.33. So 0.33 microsecond is sufficient to execute the instructions. Next will be power supply. It requires a 5 voltage DC power sources. That is enough. So that stages we use only this 5 voltages. So if nowadays we started using 3.3 or 1 volt, that time the 5 volt DC power supply is the best one. So instruction set, it supports up to 74 instructions. So this will be catered into data instructions, arithmetic instructions, logical instructions, branching instruction, and control operations. So data transfer means moving a data from one register to another register, or a memory to another memory, or a memory to registers, or different cases we can take it. Similarly, we can take this arithmetic instructions like an addition, subtraction, increment, decrement, so many arithmetic operations we can perform. Here there is no possible of performing a multiplication division, only that addition, subtraction, increment, decrease will be possible. Similarly, logical operations like an AND operation, OR operation, XOR operation, everything we can perform using this microprocessor. Branching operations, so we have two types of branching, conditional branching and unconditional branching. In conditional branching, we check the conditions. In unconditional, there is no condition will be checked, directly it jumps. So we have a branching instruction like a jump on carry, jump on no carry, again jump on parity, jump on no parity. So all the flags can be checked. So whether the present or not, we can say it is a jump on carry or jump on no carry. Similarly, we have some control operations. So based on control operation, we have the instructions that is called control operation instructions. Architecture. This is a simple architecture. It includes ALU, registers, control unit and buses for a communication. So this architecture especially, so it is called as accumulator based processor. That means all the operation will be performed through accumulator only. So for example, if you want to add two numbers, always one data must be present in accumulator. After adding that, the result also updated to the accumulator only. No other register will be possible. And it has supports this interrupt system. So it offers 5 interrupt sources for handling external and internal interrupts. Also we can set a priority also. So both internal and external interrupts will be available. So we have RST 5.5, 6.5 and trap. These are the external interrupts. And serial communication, it supports serial I/O using the 2 pins. One is SID and another one is SOD. Serial input data, this is for input data. SOD, this is serial output data for sending a data. So this will be useful for communicating a microprocessor to some other microprocessor or a microcontroller or a PC, any other things. Thank you.